Hello everyone, my name is Chen Guangwei. I'm second-year master student at Institute of Electronics, National Yangming Jiaotong University by Advisor Zhang Xijia. It's a great pleasure to introduce our lab and latest research. Our lab advisor, Professor Zhang Xijia's academic journey is truly remarkable. He holds advanced degree in electrical engineering, including bachelor, master, and a PhD degree from the National Jiaotong University in Taiwan. Professor Zhang Xijia has played a key role throughout his career, significantly shaping the tech and innovation landscape. He started as a manager at MediaTek, showing his leadership in the OSPD1 from 2002 to 2003. He then advanced to become the crucial technical consultant at Mechatronics starting at 2007. In 2010, he became the professor in the electrical engineering department at the NCTU. Here, he continues to inspire and guide the next generation of engineers. In addition, his interest in innovation motivated him to create a new startup, Wale Technology, in 2016, where he took on the role of the founder and the CTO. His research interest in algorithm and various architectures in signal processing, especially in the domains of error correction codes, crypto systems, and artificial intelligence, and he published more than 100 IEEE journal and conference papers and more than 50 patents. Our laboratory is called OASIS Lab, which stands for the Optimized Application-Specific Integration System Lab, and is established in February 2003. Currently, there are 1 PhD and 13 master degree students, and we have 3 research teams: Ocean Group for Overcome Error and Noise, Star Group for the Security, Trust, and Reliability, and the ML Group for the Machine Learning. Our recent graduates over the past 4 years went to well-known IC design house or EDA companies like MediaTek, Novatech, Realtek, and Synopsys. And here I'm going to introduce our research teams. First is our Ocean research team. Ocean is short for Overcome Error and Noise, which focus on implementation of channel coding, also known as error correcting codes. Channel coding is used to protect digital data and prevent data loss during the transmission. It is widely used in a storage device, such as hard device, flash memory, and storage class memory. And it can also be applied in a communication system, such as cell phone, digital television, wireless local area network, ultra-wideband communication, 5th generation new radio, and beyond 5th generation communications. Our Ocean Group recent research includes LDPC decoder in SSD application, and a low latency error and erase resonance decoder. And next is our STAR research team. STAR is short for Secure, Trust, and Reliability, which focuses on the crypto system and the hardware security, especially the architecture design and the chip attack analysis. Crypto systems are the set of the protocols designed to secure communication, and there are various encryption and decryption algorithms to protect the security of the data during the transmission. The main goal of the hardware security is to conduct security analysis and protect the crypto chips. There are many types of crypto systems, such as elliptic curve cryptography, authenticated encryption with associated data, cryptocurrency like Bitcoin, and post-quantum cryptography. And it can also use in memory system like memory authentication, database, and storage. Our STAR Group recent research includes a general-purpose ECC engine with side-channel attack countermeasures, and a low-latency SRP5 cryptography engine with a PUF as a root of trust. And last is our machine learning research team. We focus on developing specific model architecture using machine learning techniques for a wide range of applications. Machine learning is used to extract features from data and apply machine learning models. Our machine learning group's research directions are highly diverse, such as speaker analysis, biomedical image segmentation, semiconductor data analysis, and more. Our recent research includes configurable online speaker dialyzation, 3D MRI brain tumor image segmentation, and PCB defect detection. And also, our machine learning group is eager to join AI competitions. In 2002, we joined the TJCAS competition. We utilized XGBoost ensemble learning approach, combine various neural networks to classify different crops. At the same year, we participated in the Synopsys AIoT design contest. This contest is a competition for embedded AI and IoT. We use the Synopsys R embedded processor for face verification on an edge device and integrated gesture recognition to achieve a touchless control panel. And in this year, we took on this competition once again. We have implemented a real-time analog gauge reader for traditional factories. The introduction to our lab is over, and here I'm going to talk about our latest work in machine learning group, an end-to-end neural network with clustering enhancement for configurable online speaker dialization. Let's start with the introduction. So what is the speaker dialization? During a speech, human voice actually contains an amount of information. For example, the accents of the speaker, the language being spoken, the content of the speech, or even the emotion conveyed while speaking. This task aims to extract some specific information from speech. One such task is speaker dialization, which is used to determine who spoke when. And what is the difference between the speaker dialization and speaker recognition? The speaker dialization deals with the issue of multiple speakers in each speech utterance, and we want to separate the audio segment of different speakers. The speaker recognition deals with only one speaker, and we want to know who is speaking. There are three main design challenges for speaker dialization. The first challenge is multiple speaker and the flexible speakers problem. The second challenge is speech overlap, and the last challenge is real-time processing. Here is our proposed framework. First, to realize real-time processing, we introduce a method called streaming rolling buffer. This rolling buffer divides a long audio into small sequences. We sequentially fed into the model, and we do some preprocessing. In the first step of preprocessing, we use MuGaN for a super resolution to enhance the audio quality. The second step of preprocessing is preemphasis. This process passing the audio through a high-pass filter to enhance the higher frequency, which typically corresponds to a human speech segment. Next is a speaker dialization model. The end-to-end segmentation model consists of three main components. SyncNet is for feature extraction. LSTM enables the model to learn a temporal dependency among data. Fully connected layers serve as the final classification layers. Because the number of speakers may increase over time, we use incremental clustering to solve this issue. We map in the speaker embedding to represent the speakers, and decide if the embedding belongs to existing cluster or not. By this approach, we can dynamically adjust the number of speakers. In the post-processing stage, we select the threshold for the clustering, and then we can get the result of the speaker dialization in real time. And here is our demo video. In this video, we will see our proposed model applied to a popular podcast in Taiwan for real-time configure speaker dialization.
欢迎收听百灵果 News， 这里是华语界最自由双语国际新闻。
Welcome to 百灵果 News, the free international news podcast in the Chinese-speaking world.
我是凯莉
This is Ken.
我们会用百灵果双语的方式与大家聊聊世界各地有趣的新闻。
We'll be using both English and Mandarin to talk about interesting news happening around the world.
你也讲太快了吧？
今天很急啊！
没有，因为我们刚把范姐赶走，好爽哦！
不是，我们今天时间不够，要赶快开始。
是因为敏迪一早来，然后跟我们聊了1个小时，然后给我们看一些奇怪的影片，然后我就想说，你们要开始，你们知道今天很赶吗？
给我看影片的时候，我还跟他说拜托我们到边边去，因为
对这个影片有点奇怪，
很怕我被员工告这样。
And that's all for me today. Thank you for your attention.